Welcome to the discussion on problems on projection of straight line inclined to both the planes. Under this, we are discussing 10th problem, and this is the second problem under midpoint concept. Now we'll enter into the problem. This is the second problem we are discussing under midpoint concept. And this problem is very important, and it was asked many times under JNTU and Anna University examinations. Now we'll read the problem. The given problem is a 100 mm long line PQ is inclined at 30 degrees to HP and 45 degrees to the VP. Its midpoint is on VP and 20 mm above the HP. And P is in third quadrant and Q is in the first quadrant. Draw its projections. Now we'll extract the data from the problem. Now we'll extract the data from the problem. Here in the problem it is mentioned that a 100 mm long line PQ is inclined at 30 degrees to the HP and 45 degrees to the VP. That means here the true length is 100 mm and its inclination with HP is denoted by theta. Theta is equal to 30 degrees and its inclination with VP is denoted by phi. Phi is equal to 45 degrees. Its midpoint is on VP and 20 mm above the HP. So in the case of orthographic projections, the front view projections are denoted by lowercase letters with prime and top view projections are denoted by lowercase letters without prime. Here, the front view image of the midpoint M dash is 20 mm above XY and top view image of the M is on XY line. And NP is in third quadrant. That means its front view image comes below the XY line and top view image comes above the XY line. And the Q is in the first quadrant. That means its front view image comes above the XY line and top image comes below the XY line. And this is the pictorial representation of the information supplied in the problem. Here P1 dash, M dash, Q1 dash is the true length of the line and which is equal to 100 mm. And P2 M Q2 is the true length of the line and which is equal to 100 mm. P1 dash M dash Q1 dash is the true length of the line in front view. P2 M Q2 is the true length of the line in top view. P1 dash M dash Q1 dash line is making an angle theta degrees to the HP. P2 M Q2 line is making an angle 5 degrees to the VP. That is, theta is nothing but true length inclination with HP. Phi is nothing but true length inclination with VP. Here theta is equal to 30 degrees and phi is equal to 45 degrees. And midpoint M is on VP and 20 mm above HP. In the case of orthographic projection of points, the front view points are denoted by lowercase letters with prime, top view points are denoted by lowercase letters without prime. Then top view of midpoint M is on XY and front view of midpoint M dash, that is 20 mm above XY. And then point P is in the third quadrant and Q is in the first quadrant. NP is in the third quadrant means its front view comes below the XY line and its top view comes above the XY line. NQ is in the first quadrant means its front view comes above the XY line, top view comes below the XY line. Now we'll write the data. While writing the data, we need to recollect the basic terminology used under projection of straight line inclined to both the planes. Here, true length of the line PQ is equal to 100 mm. Here, true length of the line is nothing but P1 dash, M dash, Q1 dash. Then P2 M Q2, which is equal to 100 mm. M is the midpoint. Then P1 dash M dash is equal to M dash Q1 dash is equal to 50 mm. Then P2 M is equal to M Q2 is equal to 50 mm. Then true inclination of the line with HP is equal to theta. Theta is equal to 30 degrees. True inclination of the line with VP is phi. Phi is equal to 45 degrees. What else given in the problem? Position of midpoint M. M is 20 mm above HP on VP. So M dash is 20 mm above XY line. M is on XY line. Then point P is in the third quadrant. So its front view comes below the XY line, top view comes above the XY line. Point Q is in the first quadrant. So front view comes above the XY line, top view comes below the XY line. Then we need to draw the final projections, that is P dash, M dash, Q dash and P, M, Q. Here P dash, M dash, Q dash is the final projection of the line in front view and P, M, Q is the final projection of the line in top view. Now we will see brief overview of the solution of the problem. As I said earlier that P1 dash, M dash, Q1 dash is the true length of the line in front view and its inclination with HP is theta. P2 M Q2 is the true length of the line in top view and its inclination with VP is phi. Our objective is to draw final projection of the line in front view as well as top view. Here P dash, M dash, Q dash is the final projection of the line in front view and P, M, Q is the final projection of the line in top view and P dash comes on the same line and Q dash comes on the same line and P dash is below XY line, P is above XY line, Q is below XY line and Q dash is above XY line, as endpoint P is in the third quadrant and endpoint Q is in the first quadrant. That's why we got P dash below XY line, P above XY line, Q dash above XY line, Q below XY line. Now we'll see detailed construction related to this problem. Before going to the detailed construction of the present problem, I am advising you refer earlier video on midpoint problem so that you can easily understand the present problem and revise the basic terminology, concepts and procedural methodology used under projection of straight line inclined to both the planes. Now we'll enter into the detailed construction of the present problem. Now we are drawing solution to the midpoint problem. As a first step, draw XY line. After drawing XY line, then draw projector onto the XY line. After drawing the projector, locate image of the midpoint both in front view as well as top view. Its front view, say M dash, is at a distance 20 mm above the XY line. Here at a distance 20 mm above the XY line and M is at a distance 0 distance, that means it is on XY line. After locating the midpoint on the projector, then draw locus line at M dash. In the problem, it is mentioned that the true length inclination with HP is 30 degrees and true length inclination with VP is 45 degrees and M is the midpoint of the line. So at M dash with an angle of 30 degrees to the HP, draw inclined line, and at M with an angle of 45 degrees to the VP, draw an inclined line. This line is making an angle 30 degrees to the HP. And this line is making an angle 45 degrees to the VP. Now with compass, half of the true length, say 50 mm as a radius, M dash as a center, draw an arc on 30 degrees inclined line
left as well as right to M dash. Similarly, with M as a center, half of the true length as a radius, draw an arc left as well as right to top view of midpoint M on the inclined line. After that, name these points as, say this is P1 dash and this is Q1 dash. It is Q and this is P. P1 dash, M dash, Q1 dash is the true length of the line in front view and it makes an angle 30 degrees to the HP. P2 M Q2 P2 M Q2 is the true length of the line in top view and it makes an angle 45 degrees to the VP. After that, we will draw locus lines at P2, Q1 dash, P1 dash, Q2. After drawing locus lines for P2, P1 dash, Q2 and Q1 dash, then we will draw apparent lengths in front view as well as top view from the given true lengths. As a first step, we will draw apparent length in the top view. For that, we will draw projectors from P1 dash as well as Q1 dash towards this reference line. Because M is on reference line, so we need to draw the projectors from P1 dash as well as Q1 dash towards this reference line. Draw projector vertically down, that is from Q1 dash draw projector vertically down towards this reference line. From P1 dash draw projector vertically up. Then this projector cuts the XY line at P1 and this projector cuts the XY line at Q1. Then join P1M Q1. This is apparent length in top view. Now we will draw apparent length in front view. For that, draw projectors from P2 and Q2 towards the VP. So from P2, draw projector vertically down. From Q2, draw projector vertically up. After that, parallel to XY line, passing through M dash, draw a line. That line cuts the projector coming from P2 at P2 dash, and this line cuts the projector coming from Q2 at Q2 dash. Say P2 dash and this one Q2 dash. After that, we will draw final projection of the line. For that, what we have to do? We have to rotate the apparent lengths by fixing midpoint both in front view as well as top view and rotate these two ends towards the respective locus lines. First we'll draw final projection of the line in front view. How we'll draw? For that, M dash as a center, MQ2 dash as a radius, draw an arc on the Q dash locus line. Name this point as Q dash, then M dash P2 dash as a radius, M dash as a center, draw an arc on the P1 dash locus line. Name this point as P dash. After that, join P dash M dash Q dash. P dash M dash Q dash. Please remember, this line need to pass through M dash, that is P dash M dash Q dash to be joined together, and it is the required line. That's why it has to be more darker than the earlier drawn lines. After that, we'll draw final top view. For that, what we have to do? MQ1 as a radius. MQ1 as a radius. M as a center. Draw an arc on the Q2 locus line. Name this point as Q. Similarly, with the same radius, as we know that MP1 is equal to MQ1. So with the same radius, M as a center, draw an arc on the P2 locus line. Name this point as P. Then, as we know that this PMQ is the final projection of the line in top view. So it has to be dark. That is, it is as dark as P dash M dash Q dash line. So we need to join P and Q passing through M. After that, if you join P dash and P and Q dash and Q, then these lines are parallel to M dash line. Now we will do the dimensioning. Here P1 dash M dash Q1 dash is the true length of the line and its length is equal to 100 mm. P2 M Q2 is the true length of the line and its length is equal to 100 mm. The midpoint image in the front view, say M dash, is 20 mm above XY line. Here all these dimensions are in millimeters. Next, P1 dash M dash Q1 dash is the true length and its inclination with HP is equal to 30 degrees. P2 M Q2 is the true length in top view and its inclination with VP is 45 degrees. Then here in the problem it is mentioned that one end of the point P is in the third quadrant, another end of the point Q is in the first quadrant. That is, if the point is in the third quadrant, what about its front view and top view? If the point is in the third quadrant means front view comes below the xy line and top view comes above the xy line. So P, that is top view of point P, is above xy line and front view of point P, that is P dash, is below xy line. So this condition is satisfied. Related to another end Q, the Q end is in the first quadrant. So its front view comes above the xy line, top view comes below the xy line. So Q dash is above xy line, Q is below xy line. Even this condition is also satisfied. Then we'll move towards pencil usage. Here, when compared to true length, say P dash, M dash, Q1 dash, P2, M, Q2, and apparent length in front view, say P2 dash, M dash, Q2 dash, and apparent length in top view, say P1, M, Q1, the final projection of the line should be more dark. What are the final projection of the lines here? P dash, M dash, Q dash, that is final projection of the line in front view. Then P, M, Q, final projection of the line in top view, should be more dark. Generally, most of the students feel it is little bit confusion and difficult problem. If you go through the conceptual procedure, then this problem is not difficult. If you go through the concepts, then we can solve any problem with ease. It is very important problem, and it was asked many times under JNTU and Anna University examinations. That's about the solution for the given problem.
Visit again for more videos on engineering graphics. The links provided under description of this video. Keep learning and knowledge sharing. If you have any queries, you can mention under comment section under this video. I'll respond.